Hey everyone, my name is Jeff Williams. I'm very excited to talk with you today about the magic of security instrumentation. I started writing software back in 1983, and I've spent my whole career in software and security. Today, I'm the co-founder and CTO of a company called Contrast Security, and we offer a complete application security platform for DevSec Ops native testing and protection. First, I want to start by telling you a little bit about just how vulnerable Java web apps and APIs are. If you think of this iceberg as your typical web application, the stuff below the waterline is all your libraries and frameworks. That's about 79% of your total code base. And then the stuff above the waterline is your custom code. Now, if you look at how this lays out, most of the vulnerabilities are in your custom code. There's a few vulnerabilities in your libraries. But the thing that jumps out is that most of your libraries are actually not even used. They're just along for the ride. So I want you to focus on where your vulnerabilities really are. You need some technology to help you find those vulnerabilities quickly and accurately. The other piece is that you've got to know that your applications are actually being attacked. This is some data that we've collected from about 10,000 applications of various types. And what you see here is in 1 month, over half of the applications have been attacked with typical attack techniques like SQL injection and path traversal and reflected XSS. We also see a lot of attacks on known vulnerabilities, like this CVE 5638 is the CVE, the library problem that caused Equifax so much trouble last year. And on down the list. So the attacks are out there. You probably have vulnerabilities. So that's a very dangerous situation for folks to be in. So application security is a huge problem. On average, applications have 26.7 vulnerabilities per app. That is a crazy number. Imagine if that was airplanes. And even worse, that number hasn't changed since 2002. And even worse than that, it's the exact same vulnerabilities. How embarrassing. Look, it's not like we haven't been trying. After decades of standards and models and movements and websites and OWASP and so on, many of which I helped with, we've made basically zero progress. Why? Well, you may have noticed that development and security generally don't work together very well. Now, I'm not trying to blame anybody here. I've worked in both development and security, and I have tremendous respect for both. And actually, everyone's trying to do the right thing. The traditional approach to security is inherently adversarial. Development is optimized for getting code into production, and security is optimized for finding problems. That's the core of the issue. I want you to imagine that this car is an application that we're building. And when it's done, our car's going to have a bunch of cool features. It's going to have what let's call it business code. It's going to have engines and wheels and seats and so on. But we also want a bunch of security code in our car, right? Like things like defenses and safe libraries and secure coding patterns and security testing and so on. We want that in there too. Let's call that security as code. Now, how many of you have seen security requirements documents that are huge and that you really don't read? Or a secure coding guideline in some documentation portal that nobody ever goes to? Or some secure coding training course that you slept through? Look, again, I'm not blaming anybody, but the approach that we're using to application security isn't working, and we know because the security code isn't making it into the final product. It's just not there in the right places. So I think security tools are the problem. We have to have tools. The problem is so big that automation is the only way to deal with it. I've worked with many companies who have hundreds or thousands of applications. But the standard tools have problems, like false positives, and you have to do a bunch of extra steps to use them. And they generate a ton of security backlog. They slow down your pipeline, from minutes to hours or days. And you have to get exceptions to go into production for things. Security and development are never going to get along until we're not constantly dumping problems on each other. So
why are these tools so inaccurate? Well, in my opinion, it's because all these tools work from the outside in and therefore lack context. They don't know what's going on inside the application. So there must be a way for security tools to get better context.
So today I want to talk about an approach towards dealing with that problem. We see it in three parts. We see that you have to do something different in development. I think the right way there is to get feedback directly to developers through the tools and process that they're already using. It's got to be accurate, and it's got to be in real time. Anytime you delay that feedback or make it inaccurate, development teams just can't use it. So the goal there is to eliminate most of the vulnerabilities early in the life cycle. Some people call that shifting left. And the idea is, let's get clean code out of development and checked in. Now, that doesn't mean we should give up on doing security later in the process too. We want to be sure that the things that we put into production have been checked for security. So we need to do something in our QA and test environment. Here, we don't want to slow down builds. We want accurate feedback, and we want to potentially break the build. If a vulnerability has snuck through out of development and made it into QA test region, then we might want to break the build in order to make sure it gets fixed before it goes into production. And then the last piece is in production. We have to change our game here. Most organizations have no idea who's attacking them or how they're attacking, what techniques they're using. They don't know which URLs and which apps are being targeted. That's a very dangerous situation. So we want to get awareness of those attacks, and we also want to be able to prevent those attacks from actually exploiting vulnerabilities so that we're safe. Even if we have vulnerabilities in production, we want to be safe. This is at the high level what we want to achieve at each of these three stages. We're going to empower developers, assure our QA and test as we deploy, and we're going to protect in production. So
let's talk about instrumentation. So in the real world, when we build complex things like planes and cars and factories and space shuttles, we instrument them. In fact, you'd be crazy to operate those things without great instrumentation. But software, which is arguably the most complex thing that man has ever built, we have basically zero instrumentation. Log files are not instrumentation. They're full of garbage. They're not real time. We need real instrumentation. And instrumentation revolutionizes industries. I've got a ton of examples, but I only have time for one here. This is the 9450. It's an instrumented basketball. It tells you your dribble speed, how your shots are rotating. It measures the arc of your shot, makes and misses, and a bunch more. It also has a bunch of drills and metrics when you get the app and you hook it up to your headphones. Now, I've been playing basketball for a long time, and after 1 hour, the 9450 let me know I was shooting too flat. I had no idea. It's amazing. I didn't need an expert coach. I didn't need a bunch of extra steps. I just did it myself. All it took was a few sensors directly in the basketball. And just think about all the kids in the world who can't afford a coach. That's the power of instrumentation. It scales dramatically. Now, instrumenting software is easy. I can write, and you can write, an instrumentation agent that automatically instruments any code that you're interested in. It's amazingly powerful. You can monitor anything. You can even enhance anything. You can make exactly the changes you want surgically in an application in exactly the right place every time. So this is a picture of the Java Instrumentation API. It's standard. You're almost certainly using it already because it's part of many software stacks, particularly in the Java environment. And all it does is allows you to modify code as it's being loaded from disk into memory. You get an opportunity to add a transformer, and you can change that code however you want. Now, this isn't very new. In fact, software instrumentation has been around for at least 25 years. This technique is exactly how tools like App Dynamics and New Relic work in the APM space. It's a very powerful way to add sensors to your application. You can get started with instrumentation right now. So here's a very simple Java instrumentation agent that shows me any non-parameterized queries that might be susceptible to SQL injection. So here you can see I've used the ByteBuddy library, which is a fantastic instrumentation library. And all you have to do is implement the pre-main method. In this case, I build an agent that focuses on anything that implements Java SQL statement and has method named execute or execute query. I add this security advice sensor to it. And all the security advice does is at the end of the method, when this method leaves, it says, hey, danger, unparameterized SQL query, and it gets the parameter and prints out, so the parameter is the query, and it prints out the full stack trace, so we know exactly what's going on. Now, all you have to do to use this is just add this agent to your application, and then you just use your application normally. You don't need to know anything about security. You don't have to know anything about testing for SQL injection. This is simple and safe and remarkably effective without any code changes for your applications. So let's take a look at how this actually works. So the first thing we want to do is we want to tell Java to use our instrumentation agent. So here we're just going to set the Java tool options environment variable. And you'll see we've got a Java agent flag here. And all it does is just point to the jar file that I just built. So we'll set that. And then we just run our application normally. So I'm just starting Tomcat here. And that's all it took. So as that application started up, we instrumented it. We've got some instrumentation in place now. And now when I just go back and I use this application, I'm going to a page in this application called Ticketbook, which has got a bunch of different vulnerabilities in it. I can just put something, I'll put Spring here and submit. And you can see that our instrumentation detected an unparameterized SQL query. It shows me the exact query. You can see that this data flowed through the application and ended up in the query, in this case, without any kind of escaping or anything. And it gave me the exact stack trace, so I can see exactly where in Ticketbook there's a method called query unsafe in the database class that probably has a SQL injection vulnerability. So that's how we do it with instrumentation. Now, you can do much more sophisticated instrumentation. Let's take a look at a more sophisticated SQL injection example. In this case, we're not only going to detect the vulnerability, we're actually going to prevent exploits in our application in production. So imagine what we're going to do is we're going to add sensors to track untrusted data from the HTTP request wherever it goes. In this case, we'll track the username. So here we've got the username parameter that comes in. We're going to track this wherever it goes. Then we're going to hit a sensor later inside the execute query method. And that sensor is going to notice that this query is built with untrusted data, and we'll dig into it. We'll take a look at that query. And what we're looking for is to see if the untrusted data that came from one of our users changed the meaning of the query. That should never happen. You should never let your users change the meaning of your queries, right? That's kind of the definition of SQL injection. And if we see that, then we can intervene and we can prevent that query from going to the database. We can even safely redirect the response. So let's take a look at what we're doing underneath here. So here's how we can know if the untrusted data actually changed the query. We can, basically what we do is we check to see if that untrusted data changed the parse tree. And in this case, you can see the attacker's single quote here. Normally it would have just stopped there and continued with the rest of the query, but in this case, the attacker's single quote introduced a new OR expression. It closed that string literal and it started a new OR expression. That's what should never happen. That's the problem. And so that's where we can use instrumentation to intervene and stop this attack. We can report the details on who it is and what where they're coming from. And if it's a compromised user account, we could even potentially block their account. Let's take a look at another example here. This is another example of how we can use advanced instrumentation. So in this example, we're going to look at the URL that was used to exploit a expression language injection vulnerability in struts. And as you might remember, that's the same kind of vulnerability that caused the Equifax breach. Now, in this case, I broke down this HTTP request into a few lines so that you can read it more easily. So the first part of this URL is normal, but then the second part of the URL here is an expression. It starts with $open brace. And you might try to signature this attack and block it with a WAF, but there's just so many different ways to write this. You can't really protect modern applications at the perimeter because they don't have enough information. So here's what we're going to do. In this attack, the attacker is trying to trick the application into calling runtime.exec with their evil expression. So what we're going to do is we're going to add some instrumentation inside runtime.exec. And then when the data comes in, later on we're going to see that we're inside the OGNL util. That's what evaluates these expressions. So we start a scope there, and if we see a runtime.exec call inside there, then we know that something bad is happening and we can intervene and stop that runtime.exec from harming us. We can do the same thing with any other kinds of harmful activities like opening files or starting sockets or creating processes, things like that. Because that should never really happen inside an expression evaluation. And so this is a really important technique. We can make it impossible for attackers to do harmful things during application execution. That makes the attacker's job immensely more difficult. We can do this for SQL injection and cross-site scripting, XXE. We just took a look at an expression language injection problem. We can do it for SSRF and path traversal and command injection and many more. The best thing is that most developers don't have to know anything about this or do any extra work. This is security as code that happens automatically. When you use instrumentation for security, the first step is to get all the sensors set up. So you add the agent. When the application starts, all the sensors get deployed. When you're using instrumentation to detect vulnerabilities during development, that's called IAST, or Interactive Application Security Testing. And it's super accurate because it's directly measuring the running app. And it works in real time, so you don't ever have to wait for scans. So it only reports vulnerabilities that actually happen. The second way to use instrumentation is to stop exploits in production. That's called RASP, or Runtime Application Self-Protection. And it's also super accurate, so you know exactly who's attacking, what attacks they're using, and what systems they're targeting. And you're safe even if your application has a ton of vulnerabilities in it. So again, you just add one instrumentation library to your application, and it sets up all these sensors to watch for vulnerabilities and attacks with IAST and RASP. And most importantly, it scales. I want you to imagine that you add security instrumentation module to hundreds or even thousands of applications. Now, all your applications will be testing themselves in parallel. Basically, you'll get real-time, continuous data about vulnerabilities, libraries, threats, and attacks continuously without running any scans or correlating results or weeding out false positives or trying to deal with PDFs. This is what I call security in sunshine. You might think of it like security observability. And this will enable you to take care of security yourself. Now, that'll free up security teams to focus on really important but mostly ignored things like threat modeling and security architecture and threat intelligence. So it's a nice way of balancing the work between security teams and development teams. So let's go back to our car. Remember, we want to have both great features and also great security code for testing and protection instrumented in. So imagine a team that's building this car using instrumentation. This team is instantly and accurately notified anytime there's a new vulnerability, so they can fix it right away and check in clean code. They've got automatic library analysis that's telling them if any of their libraries are out of date or have known vulnerabilities or have a bad license. And with instrumentation, you can tell if the library is actually used or not, so you don't get false positives. And this team also has runtime protection. So even if somehow they introduce a vulnerability into their application or a new CVE comes out in some library that they're using, they've got protection so they can see who's attacking and they know that they're safe. All without wasting experts' time. They didn't have to change any code. This is just a way more efficient, better way for developers and security folks to work together. Now, people talk a lot about DevSec Ops. Too often, they're just saying to shove all the security work onto developers. They might call it shifting left, but I think it's really just shitting left. DevSec Ops is really about transforming the work of security. Security needs to go through the same kind of change that development and operations went through. They've got to break the work down into smaller chunks to create flow. We've got to create that continuous security feedback, and we need a culture of security experimentation and learning. So security instrumentation can really help. It'll allow security teams to get really involved in building products and not just, dumping PDF files on them. So application security isn't hopeless. I'm not saying that technology alone can solve our security issues. Good security requires the right mix of culture, people, process, and technology. But security instrumentation can create a platform where security and development can finally work together constructively. If you're interested in trying out security instrumentation on your apps, I'm very proud to tell you that over 2,000 organizations are already using Contrast Community Edition. It's fantastic for Spring applications. You can use our pivotal tile to add the support for it. It's totally free and full strength forever for one of your apps. So please give it a try. Reach out and let me know what you think. And now I'd love to take any questions you might have about anything.